All right. Hi, everyone. My name is Schrock, and I'm the founder of Elemental, the company behind Dagster. Thanks so much for having me. It's really exciting to be here. And yeah, just before I get into the technology, just wanted to give a brief background on me. In a previous life, I worked at Facebook, where I founded a team called Product Infrastructure, which built abstractions and frameworks for our product engineers. That team produced React, React Native, and then the thing I'm most associated with is GraphQL, which I personally created and co-wrote the spec that became the open source technology. After leaving Facebook 2017, took some time to figure out what to do next. And I started asking technology companies in and out of the valley about what their biggest problems were in terms of technical liabilities. And this idea of data infrastructure, ML infrastructure, data pipeline, ETL, whatever you call it, data work, just kept on coming up over and over again. And I looked into it, and what I like to say is that what I saw was the biggest mismatch between the complexity and criticality of a problem domain and the tools to support that problem domain that I've ever seen. It was kind of like almost, traveling back in time or something. Just like you put the same engineer in the data space and like somehow it feels less productive and less awesome. And it's, I'm just compelled to work on these sort of developer productivity problems when I see that type of inefficiency in the world. I kind of like, as I can see a developer experience dumpster fire, I'm like drawn to that fire like a moth to a flame. And after examination, it was really the orchestration layer and the core activity of constructing dependency graphs in data systems, which stuck out at me as a critical point of leverage on many dimensions. And I'll get into that in a second. So briefly, I'll go over this quickly because I think this crowd is very familiar with the term, but what is data orchestration? And effectively, it's two things, right? It's whenever a person or a team puts a data asset into production, and by asset, I mean a file that gets produced, a table, a pickled model, whatever. It's not done in a vacuum, right? Data has to come somewhere and go somewhere. And that means dependencies, right? So that has to be managed. And then furthermore, another interesting thing is developed, even as an individual practitioner, you are building dependency graphs, right? You're building this, what we like to call data application, and you're parallelizing things. You want to make sure there's checkpoints so you can start where you left off. So even if there's another team involved, you're just developing the DAG. So these orchestration systems and workflow managers are deeply ingrained at both kind of the individual practitioner level and at the team and organizational level. And the traditional definition of workflow managers is that it simply schedules and orders computations in production. But we think that limited definition has a huge missed opportunity and misses a huge point of leverage. We think really orchestration matters because we view it as really the center of gravity of both the data platform as well as the kind of data lifecycle, the software development lifecycle as it comes to data. So there's a bunch of different people that interact with the orchestrator, right? One is you have practitioners. This includes data scientists, data engineers, anyone who's responsible for the production and maintenance of data assets. There's other people too, right? There's platform. These are folks who are responsible for supporting said practitioners. There's tons of infrastructure needs. And really, what we think their goal should be is to enable end-to-end ownership of data products by practitioners, all the way from develop and test to monitor and serving those produced assets. And lastly, you have stakeholders who are interested in data assets and even participate in the operation of data systems. We have lots of partners who end up incorporating non-technical stakeholders to in a self-serve way, monitor operations and asset production. And at the center of this is the orchestrator, our cute little friend, Dagster. So we just think this is a critical leverage point in these systems. So I referred to the life cycle. What do I mean by that? We kind of divide the world into three phases. One is that you're a Python developer, you're building data computations, right? You're developing and testing these things. Then once you've done that, you want to deploy and execute it. And then lastly, you want to monitor and observe those computations and the produced assets. There's a lot of existing orchestration systems. I'm sure a lot of you know Airflow and oriented around that. And what we hear from users of Airflow and similar systems is the following, and we'll kind of chop it up into these life cycles. In terms of develop and test, we frequently hear like, there's no way I can develop my DAGs locally, right? All my DAGs are bound to the production environment. I have to have the scheduler running in order to do anything. Just local development isn't a thing. Another thing we hear is you can't test the DAGs, right? There's no way to kind of execute them flexibly in different environments, say your laptop, CI/CD pipelines, et cetera, it's just extremely difficult. And as a result, people don't catch errors until way too late in the process, right? Often you're kind of developing in prod in some ways, which is really, really difficult. Next, once you deploy and execute these things, like Airflow in particular was not designed to be a multi-tenant, multi-team environment. All of the DAGs in a particular Airflow installation all share the same process in the same Python environment. That means there's like massive dependency conflicts. Potentially anyone can bring down the orchestrator with one errant push. And as a result, they feel like they can't reliably or independently deploy code. And lastly, there's a monitor observation aspect of this. And we hear like things are difficult to bug. Just, some of this is UI issues, but at more core is the lack of data awareness in effectively all the existing orchestrator systems that we know of. Really limits both in terms of high quality debugging tools, as well as just the ability to know where data comes from. So these are kind of the things we hear. So what I'm going to do is hop directly into demo to demonstrate what it's kind of a tautology. Yes, I'm demonstrating using a demo. We're going to show this demo to show off the system. And it's going to be this, we're going to build kind of a classic data application, a hacker recommendation engine. And it has a few stages. One is that you have this stage kind of written by a data engineer, say, where you're downloading data from the public Hacker News API. You're using Spark to compact that into Parquet and upload it to BigQuery. And then we'll show how downstream consumers of that data product use this system to build a recommendation engine and also build analytics dashboards using DBT. So this is kind of one of those classic multi-persona data platforms where you got to get everyone to look together and you want to have a unified data platform. So let's start with a dev and test life cycle. I introduce you here to who we call Dagster, STIR, the icon of Dagster with a chef, which I think is particularly cute. So why do we think dev and test is so important and such an opportunity for the data domain? And the reason is because we think this is a status quo with most data teams, that too many of their errors, software errors, programming errors, et cetera, are caught way too late in their life cycle. There are way too many errors that are caught in prod that potentially could be caught in local development or a fast CI/CD pipeline if the software systems supported it and they have the abstractions to enable that. And to use a very 2020 phrase, our goal is to flatten the curve. We're not claiming that all development can be local, because there are just certain things in data systems, as you know, that you can't test locally, right? There are like production issues, performance issues on your production data, data quality tests, et cetera. But that leaves tons of errors you can bring up this curve. And we think that one of the critical things that's preventing the flattening of the curve is the orchestration and dependency graph layer, not itself being this testable, flexible artifact. And this is a big deal because this represents an order of magnitude increase in the productivity of people and the quality of systems, because errors caught down the line are orders of magnitude more expensive than errors caught in your laptop or CI/CD pipeline. So this flattening of that curve, because the errors are so much more expensive down the line, represents like a order of magnitude reduction in cost, order of magnitude increase to the quality of life of developers, practitioners, and on and on and on. A lot of goodness comes from this. So I've been talking for a while. Let's talk about some code. So this is what Dagster looks like. Excuse me. Open source Python module, pip install Dagster. You can write code like this. We have, you decorate a function, you call it a pipeline. That's what constructs the dependency graph. So that's not actually invoking the hello world function. It's simply creating the DAG structure. And then we have our node of computation, which we call a solid, which actually performs the compute. And then as you see, we have a lightweight API where we can just execute that pipeline, and that's what hello world looks like. So let's hop and do a slightly more real example. So this is a piece of code which takes a range of IDs, downloads them from a public Hacker News API, and then plops it into a data frame, right? Classic step in ETL process. A few things to note here. One, our nodes of compute are unlike tasks in traditional workflow engines, which are simply just encode execution dependencies. We have data dependencies. So our nodes declare inputs and outputs, and they're optionally typed. We think DAGs should be typed once they're put into production, and we think there should be data dependencies. Second, the body is arbitrary Python. You can do whatever you want, invoke any computational runtime, any tool, etc. Lastly is separation of IO and compute. You'll notice that there is no call to .2 CSV or .2 Parquet, right? These are functions which perform a computation and return their logical representation. So this returns a data frame. It's a responsibility of a different part of the system to actually persist that to Parquet on S3 or a CSV on a file system or whatever. And this separation of IO compute is absolutely critical for enabling developer workflows and the testability that we want. Okay, let's actually hop into code here. So what does this look like? So the moment that you have these computations in this format, let's see, are we seeing this? Cool. The moment that you have these computations in format, you have all this tooling at this disposal. So this is a live demo on my laptop. All I typed was Dagit, which is the name of our web tool. You don't need to have the scheduler process running. You don't need to have a database running. And all of a sudden you have this kind of, what we like to think is a beautiful tool and we're going to start by inspecting this stuff. So one nice thing, we like to think this is a consumer grade UI. So you can just kind of do a global search and search for things and kind of, you can think and just type things and things pop up, which is very nice. So here's a representation of this pipeline. And you'll see here that here's that solid that I showed in the slide. And look at all this rich metadata, right? We can tell like what the inputs are, what the outputs are, there's descriptions, and every single piece of metadata that you adorn the code with will be exposed in the tooling. And this is a really powerful thing because you can load this without any infrastructure, which makes it actually a unit of documentation. It's extremely empowering just to be able to git clone one of your colleagues' work and then just type Dagit and like see what they did, right? Without having set up infrastructure. It's really, really powerful. But this isn't just a view-only thing. You can actually run ad hoc computations from here. So we have this thing we call the playground. And so let's imagine that I was developing on this. And I want to have a fast developer loop, and we want to treat this as almost like an IDE for DAGs. Flip over here, here's the actual code. And let's say I'm coding here and I make a mistake because I am bad at programming. Okay, go back here and I kick off this computation. Oh, look at that. I have the demo gods, I think, have failed me. Double check here. So now you get, it happens, right? Let me reload this. Okay. Oh, thank God. All right, everything is fine. And so you notice here, this is actually executing my laptop. We have this live updating Gantt chart, and boom, lo and behold, we have a failure. So you can click on this right here. We have this thing called the structured event log. So this is not just pure text logging. We actually log these structured events so we can have rich viewers of this. So here we have a step failure. You can view this message. It formats it as a stack trace. We can see that, yep, I am indeed bad at programming. Go back here, fix the error. And then you can do things like, I want to restart this from the last failure, right? So this provides this really nice local development loop. Now we're going to kickstart this computation. Again, it's like this nice live updating Gantt chart, which is actually quite fun to use. And lo and behold, we're off to the races. So we have this nice web tool. We can render things quite beautifully and have this local development cycle that incorporates it. But not everyone wants to work in IDE all the time, understandably. So we also have very convenient APIs for locally developing things. So here we do an invocation which actually just tests the download solid. And I'll talk about what that resources thing makes, but these are just vanilla Python functions, which you can distribute the computation, but you can just treat it effectively like a vanilla Python function right there, and just build unit tests and do TDD and all the fun stuff, if that is up your alley. Okay, so one of the things I talked about was early cycle detection, early error checking. An example of that is cycle detection. So you have a DAG, A goes to B, and you want to detect to make sure it never loops back and goes back to A, because that would be bad, things would infinitely execute. And DAG is a directed acyclic graph. So this slide is from a presentation from last year's Airflow Summit, and it was about testability. And this was the code they had to write to successfully check whether or not there was a cycle in the DAGs in their Airflow installation. And effectively, because it's so tied to the scheduler at Airflow, they had to effectively re-implement the logic of the scheduler in order to do this. So this is a lot of work. And this effectively kind of demonstrates how deeply tied in Airflow the graph structures are to the specific operating environment it's in and the scheduler. In Dagster, there's standalone artifacts, which means that you simply cannot construct them with a cycle. So literally, once you can do this, you don't have a cycle, you can move on with your life. It's just like one example of many of moving error detection up the curve by default. We like to call that the pit of success that developers fall into. But you want to go beyond what we call structural testing. You want to be able to test your business logic as much as possible of your business logic in an environment independent way. Now, the rub is, as you know, is that in data, you often have a lot of heavyweight external dependencies, object stores, databases, data warehouses, Spark clusters. So structuring your code to do this can actually be very, very challenging. And what we want to be able to do is, for example, say locally develop our business logic in Spark using a local Spark cluster on our laptop, persisting stuff to the file system, and then hold that business logic constant, and then be able to execute against against production resources. So instead of executing your local cluster, you're instead launching an EMR job and persisting the intermediates to your S3 data lake. So how do we accomplish that? The critical thing is this abstraction we have called the resource. So we flow a context object through all of our computations, heading back to the download items thing we talked about. And you'll notice here that there's a context object. We have this notion of resources. So the solid declares what it needs, and then you invoke those resources through that context. What this allows you to do is late bind what you actually call. So for example, in test, you might just hit the snapshot of the data, right? Which is what I just did locally, which made me more confident that it was going to work super reliably. And you can run a CI/CD pipeline without incurring errors from the public API. But in prod, you still want to go against requests, right? That's a Python library, but you want to go against the public API for Hacker News. So what this allows you to do is kind of minimize the amount of code that changes between the different environments, where all the other stuff is environment neutral. And it's really this layer that enables a lot of this fast lifecycle stuff. Okay, so talked a lot about the local development lifecycle and our abstraction layer. Let's go and deploy and execute this thing. So I'm going to do a fairly surface level description of this, but bear with me here. And when you deploy this thing, you're going to have to run a few services. So one is you have a long-running process or web server called Dagit. So you not only run it on your laptop, you run that same thing in production. And then we have a run scheduler, a daemon process, and its only responsibility is kicking off runs. This is notably different from Airflow and most of the systems that have centralized task schedulers. So the daemon's only responsible for runs, and we'll go into that workflow for a second. This is another critical thing, which makes Dagster suitable to be a multi-team, multi-tenant platform. which is that any code that the user writes, the practitioner writes, is not in process with the scheduler or the web server. It's invoked over an API. That means, for example, if a user pushes up a syntax error, the centralized core system simply notes that they couldn't launch this container, and then there's a little red dot in the UI and says like you have to do something, rather than the whole thing coming crashing down. And this process isolation aspect of this really is I would say the foundation for why this is such an operationally robust system. Our run scheduling is designed to be fault tolerant. So it kind of follows a reconciliation-based model similar to something like Kubernetes, which means that we do scheduler ticks and it computes what runs should exist, and then the system reconciles that. That means if the run scheduler process goes down, it will always catch up once it reboots. Also, as a distinction from most of the systems, is that we don't just do time-based scheduling in this manner, but we also do event-based scheduling in this manner. So instead of having a task that runs forever, we actually integrate sensors or event-based schedules into the run scheduler itself. And then every time we launch a new unit of computation, meaning like a process or a Kubernetes pod. This is an infrastructure neutral technology, so you can adapt it to your own system. But it runs this piece of ephemeral compute, which it is responsible for task scheduling. So this is much more amenable to having infinitely elastic compute available in a public cloud and distributes task scheduling, which generally helps the robustness of the system. So this is very customizable and pluggable, but we also come out with a kind of easy to use, out of the box, production grade Kubernetes deployment with a prefab help chart that you can get spun up with quite quickly. So what does this look like? I'm just going to go quick back to this, and I'm going to switch tabs. And you'll notice instead of localhost here, I'm actually running on demo.elemental.show, which is our Kubernetes cluster, one of our Kubernetes clusters in GCP. So I can do the same. I can use the same tools. Go to that download pipeline. Go to the playground. You notice I'm in what we call prod mode. And this is actually not going to run like on that local box, right? This is actually going to kick off Kubernetes jobs and launch the run on this ephemeral compute. So for every run, there's a job launched, and then the compute happens in the cloud. Same tools that you're familiar with, and so on and so forth. So this is taking a bit to spin up the Kubernetes job, and now we're off to the races. So this is not just your local development experience, this is also your operational pipeline. And we'll return back to that soon enough. Okay, so let's talk about the third lifecycle stage that I mentioned, observing and monitoring. And critical in Dagster is that we're not just observing and monitoring computations, we're also observing and monitoring the produced assets. And we think this is critical to a highly functioning orchestrator. So we're going to do this by adding data science. So we're going to write a pipeline which uses pandas to fetch data out of BigQuery and build a recommendation model. Well, pandas plus scikit-learn. So how does data science fit into this picture? The way we like to think about it is that a mature data platform must think across roles. So a lot of ways that what the data platform at a team is doing is enabling this grid, meaning they think about for each persona, what are they doing at each phase in the life cycle? And we just demonstrated kind of a hybrid data platform engineer owning the entire end-to-end process by building that first stage of the pipeline. But let's imagine that they're working with a data scientist. Data scientists don't like Kubernetes. They don't like infrastructure. They don't care. They shouldn't care. That's not their job, right? So we want that abstracted away from them. But we still want them to be able to own their data products end to end. And that means they need to own their dev and test lifecycle, and they need to be able to monitor and observe those produced assets and take action on that. And really, what a platform engineer really wants to do is partner with their stakeholders so that they're totally self-serve and they never have to be bothered ever again. Everyone is happier that way. So what does it look like to build a little more advanced data pipeline? So this is this story recommender pipeline, which is doing a very ML thing. It's doing some data processing, and it's building a recommender model, and then building a bunch of components in a ML lifecycle. So this is what building a pipeline looks like. It's kind of this function X DSL. This is not invoking the computations directly. This is constructing the dependency graph, and it's doing it in a data-aware way. So this ends up building a dependency graph like this. What does the code look like? So if you're a data scientist and you're using Dagster, you're writing what is mostly looks like vanilla code, right? You're using familiar abstractions and whatnot, but at the bottom here, there's something a little unusual. This is that structured event stream that I was talking about. And what this code is doing is that it's informing Dagster that, hey, I'm about to create this asset that lives at this spot, and it has these properties. And that's a really powerful thing to have the orchestrator be aware of that. And I will show you why. Just a reminder, what do we think of as assets? So it's effectively anything that outlives the scope of the computation, right? It could be a data warehouse table, a Parquet file in the data lake, a pickled model. And what we've found is this core insight that your stakeholders and people only care about the data assets. I hate to break it to you, they don't care about your pipelines. They don't care what their structure is. They don't care what they're named. No one cares. They only care about your assets. And how does that end up materializing in the system, to overuse that phrase? So if we go back here to demo the elemental.show, I'm going to go to the story recommender pipeline. So this is this thing that we built. This is, a little more intricate. We have runs here. There's a couple of interesting things. So one, I'm going to show you how we just ended up having this run kicked off and completed. And what we had was that this was actually configured to run every time the upstream table was updated. So we're in a completely separate DAG, but we're using sensors to kind of connect those DAGs. So this is kind of fun. If we go down here to the story recommender sensor, this is the way we track these sensors. So what this is doing is about every 30 seconds, it's seeing if that table is updated. It does that by querying the metadata in our asset catalog. And you see how this is like a live updating UI. It's very fun. And here, it kicked off this run, okay? So if we go, and this is the run that got kicked off, and look at it, what I'm gonna do here is we're talking about assets, right? So this pipeline has generated a bunch of assets, and it's done it with our structured event stream. So I can go here and type and search for all the asset materializations, and boom, there it shows up. Here are all the things that have been generated by this computation. So we can go here, we have all the structured information. So we can say like, okay, here are the data frame columns, that's interesting. But then there's also this link here. And we can go and click on this. Let's go to the recommender model. And I want to see what the history of this asset is. And I load this and like, there's all this interesting information. So look, we have spark lines here. We can track what's been happening to the step execution over time, see what the total explained variance ratio is, see what's going on here. And it's a structured event log that tracks what's been happening to the stuff over time. The other really interesting thing about having the orchestrator be asset aware is that it's entirely new way to index the orchestrator. So imagine that you're a stakeholder and you don't know anything about these pipelines. You don't know, you don't care. But what you do know is that you're looking at a stories table in Snowflake and something's off. And you want to know what the hell is going on. Well, you can go right in here, search. Oh, look, here's the stories table in Snowflake. Boom, launch into that. All of a sudden, I see this interesting information. Imagine it had been run for a few days or something, and you see that's out of date. Then you're like, wait, what pipeline actually did this? You can click on this and see like, okay, this is the pipeline that did it. Oh, here are the owners, right? So this really allows stakeholders to kind of index into the orchestration system by assets. So instead of saying, seeing the stories table be wrong, panicking and blasting Slack or email list or whatever, they can just go in the tool and do a lot of the routing self-serve or potentially even re-kick off pipelines, which we have users do. Going back to this demo, again, wanted to talk about the sensors concept because we think it's really powerful. The way that these pipelines operate is that there's an upstream pipeline, there's an upstream team that manages a pipeline, and then a downstream team. And a very common pattern is to create these mega DAGs, where like your whole data platform is in one or very few huge DAGs. And we think you should be able to componentize this a little more, but without tight coupling. So they should be able to deploy their pipelines independently. They should be able to use different Python environments, et cetera, et cetera. But the nice thing about these sensors, and what these sensors do, is they agree on an asset key in our asset catalog. So literally, when we built this demo pipeline, what happened is that the data science person and the data engineering person, they simply agreed, hey, the stories table is our contract. And then from that point on, there was very little coordination, right? Team one developed their pipelines completely independently. They determined names, they determined the structure. Same likewise for team two. But these asset sensors as loosely coupled inter-team dependencies, we think is a really exciting way to work. And we're really looking forward to doubling down on this. You know, it was kind of like, this was the phrase I was uttered aloud. I didn't know anything about their pipeline, and it was absolutely beautiful. I'm going to quickly talk about analytics engineering, because I assume this crowd is familiar with DBT. And, you know, let's talk about, okay, now the DBT analytics engineering team wants to hook onto this and take the assets produced by the data engineering team and then construct a bunch of tables in their cloud data warehouse for analytics, dashboards, et cetera. So if we go back to this picture and you're a DBT user, you might see like, oh, okay, what goes in the dev and test box? Because I really like DBT and I don't want to change that. I develop in it, I think in it, and you know, we agree that you should continue to do that. Dagster does not proclaim to take over the kind of DBT developer experience. We consider DBT a highly philosophically aligned system that really thinks about data computations in the same way, meaning that, you know, the nodes of computation should be pure functions. You should depend on upstream data. And, you know, it's really in a lot of ways, you know, from our perspective, takes a lot of the philosophies of Dagster and applies it to SQL-only computations over data warehouses. But where Dagster really comes into play for someone who uses DBT is operationalizing DBT in the context of other things. So effectively, like you want to write some Python to make DBT work with the rest of your tools, or maybe even operationally harden DBT. And then you want to use Dagster in those contexts to do cross-cutting monitoring observability. So this is what a DBT integration looks like. It's very straightforward to create DBT solid. You just kind of effectively, you know, provide where your profiles and your project live, and you're good to go. And then just quickly, you know, this isn't super profound, but it's working. We hooked up the DBT pipeline in the same way with sensors. So you'll see that this run just happened a few minutes ago. And if we go, we can check out the DBT on hdownload finished, and oh, we missed it. So we go one day here. These are really fun UIs, actually. You can see this is where it got kicked off. Okay, that's interesting. Go here. And then you can use the same tools to, for instance, track all the things that are created by a given DBT run. So you can say, okay, I want to see the asset materializations here. Okay, look here, interesting. Here are all the models, you know, here are all the database tables that were created. Here's all this information about it. So once you actually hook up the DBT integration, you kind of get all this stuff for free. You can keep track of execution time. You can keep track of how many rows happen. You know, you can even see sample data. You can configure that if you want, if there's PII or whatever. But you know, this tool is a very rich way for the orchestrator to become data aware, and our users really find that it improves debuggability and whatnot. Okay, so to finish this up, 1 second here. Oops. You know, we think that orchestration is a huge both problem in data currently and a huge point of leverage and an opportunity, because the orchestrator shouldn't just order structured computations in production. We think it should be data aware. The computation should be connected with data dependencies. It should feel like a productivity tool with a fast dev and test lifecycle. And by being data aware, dramatically improves the observability and debuggability of this thing. So like I said, it embraces the full lifecycle: dev and test, deploy and execute, and monitor observe. And you know, what we're a really sweet spot we've found is that data platform teams, or people who are platform thinkers, really tailor very nice end-to-end dev workflows for their practitioners. So it's an open source project. So we have a GitHub, we have a very active Slack, and we have what I think is a very nice doc site. And I will finish up there and take questions.
Awesome. Thanks, Nick. It's been great. Okay. Cool. What did people think about the talk? And what questions would you have for Nick?
I can sign off if you guys want to trash it. No problem.
No, the talk was awesome. Let me ask you this. So what would be your advice for someone who's coming from Airflow? So there's several parts here, right? Like there's learning the tool, reading the documentation, that kind of thing, but also there's porting a lot of old Airflow code that you have laying around or actually running in production over to Dagster. What would be your general perspective on that?
So funny enough, we have I have some additional slides just for this type of question.
Oh, great. Okay.
So we built a very flexible and pluggable system. And one of the things that users have done to kind of dip their toes in the water, especially in cases where there's a grumpy infrastructure team that doesn't want to deal with a new tool, which I completely sympathize with. 1 second here. Is that, so we have the ability for you to write Dagster pipelines and actually compile them to Airflow Dags. So you get a lot of the local dev and test experience. You still have to run the computations on Airflow, but you can actually get a sense of kind of like the programming model and the APIs. So how that works is like, imagine you have this Airflow installation. There are DAGs encoded in Airflow, and data science, they're like, oh my God, I want to use a new tool. And the ops people are like, get out of here. Like, another tool, no. And again, I understand that. So we have this, what we call, Dag Injection. So the Leaf developer will develop code in the Dagster API. And then what they could do is in their Airflow DAG construction, they can simply create an Airflow DAG and take the pipeline that's created in Dagster space. And that actually generates a Airflow DAG that they're all one type of operator. So like it invokes the Dagster computation, and this allows you to run over infrastructure. We have Mapbox does this, and they've actually recently done a blog post. And what was cool about that is that they actually 50% of their compute spend was actually spent in R&D because they were developing against their production clusters. And they were able to switch to Dagster and do more local development and development also on ephemeral EMR clusters. And it actually cut their spend so much that the managers thought that there's something wrong. And then they're like, no, it's actually fine. So this has been effective for a bunch of our users. Then, is more kind of, I can start there. So, in terms of, that's kind of one strategy for dipping your toes in the water in terms of using that injection thing. But, I think, when you first start out, I would just kind of build, take something that you would have built in Airflow and build it in the system, and work through our docs. And then, I think what I was describing was kind of more how to, introduce it incrementally into our organization. Because I am an ideological incrementalist and think that you should have multiple points of ingress into these types of systems. Feel free to follow up with any other questions.
Did that answer your question, Matt?
It did. Yeah, I have many questions, but other people should jump into questions. Jared, do you have a question?
Yeah. First off, thanks for the presentation, Nick. This has been awesome. It's exciting. It mirrors a lot of the conversations we've had internally on some of the problems we're facing at Weave, and how, as an infrastructure team, we want to kind of enable people better. So that's really exciting. One of the issues that comes up for us is kind of empowering teams to use their own language of choice, right? We run a lot of our stuff in Kubernetes, and Python definitely, I think, is the right choice as a language for data for the most part, but sometimes that's a hard sell for teams who aren't familiar with it and don't maybe want to support multiple languages. Is there any thought or consideration for just being able to use containers as pluggable pieces rather than Python functions, or something else in that space?
Yeah, so it's a good question. There's nothing that prevents you from writing a solid that only launch as an external container, right? So I believe, so yes, you're kind of like opting out of a lot of the programming model effectively by doing that, but you can at least integrate other things. I think in the short term, we're very focused on Python. We have users who like invoke Scala jobs and computations in other languages, and it's effectively kind of just launches an external process, and Dagster doesn't know that much about it. We don't want to bite off more than we can chew, but certainly the long-term vision of this is multi-language. In terms of, if you recall the chart, our tools interacted with our user-defined computations over an API. And so where we want to get to is get Dagster to a stable API and abstraction layer where that API can become a standard. And then you can imagine effectively Dagster being implemented in other languages so that you can interact with this in a kind of have the tools cross different domains. I think the first instance of that, we have users actually doing this already kind of in a hackneyed way, but fully supporting, for example, like querying DBT projects and actually importing the entire graph of a DBT project into Dagster space. And then we can do way more to help out DBT users with orchestration that way, for example. Because DBT is typically just like run everything all the time, right? And they kind of like rely on the cloud data warehouses to take care of that for you, but that does fall apart at some point. Currently I would say our multi-language support is bare bones. We have like a library which can launch a Scala job, a Spark job that's encoded in Scala, for example. But as the system grows, I really do want to mature it so that we can incorporate multi-language in a much more rich way. So like, for example, I think the first step would be getting that Scala Spark job to be able to emit those structured events and inject rich information into the observability stream, as an example. It's like decent at best right now, but looking forward to investing in that in the future.
Awesome.
What other questions do people have? Matt, you have like a whole encyclopedia. Ferris as well. I mean, if he's still here, he may have dropped off.
Is Ferris around? Yeah. Put Ferris on the spot. I'm sure he has.
He might be taking care of his child right now. So okay. Yeah, Matt, what do you got?
So another. I muted myself. Okay, you guys can hear me. So let me ask you a pragmatic question. I think the complaint I've heard from people, mostly switching to Prefect. I kind of heard about Prefect before I heard about you guys. The main complaint was not about the tool itself. It was mostly about mindshare. And then from my perspective, the other big issue is managed services. So those are like two advantages that Airflow has right now. Huge mindshare, lots of people using it. And then there are several vendors that have managed services. So you don't have to manage clusters or anything like this. You may have said this in your talk, but like, what do you guys have in terms of managed services? And then I guess this talk is part of the move to expand mindshare, but what are your perspectives on growing the mindshare for Dagster?
Totally. So great question. So if you want to help us grow mindshare, as I mentioned at the beginning, we do have an open position for head of DevRel. So first of all, obviously with newer tools, there's not going to be as much mindshare as the legacy tool. And you have to believe that the value is big enough to warrant that. So, this is kind of classic adoption curve in technology. Like not everyone's going to adopt everything all at once. Everyone has different risk tolerance and the willingness to deal with newer technologies. So like that is what it is. We strive to have super high quality documentation. We strive to have a super responsive Slack community. But we need to grow the community and expand that corpus of knowledge on the internet. So, in terms of, we've been developing this out in open for a while. I almost referred to it up until this point as more of like an applied R&D project, meaning like we're supporting very real clients, but we also wanted the flexibility to make changes and to evolve the technology. And we're really reaching an inflection point where we really feel like we know we have delivered something of value, and the people using the system currently are getting a ton of benefit out of it. And kind of the next stage of the company is two things. One is really accelerating our growth trajectory, and two is without divulging too much, there's a commercialization in the works, and I think certainly a managed service will be a component of that. So, Airflow was actually, Airflow was started in 2014 at Airbnb. It actually stems from a system called Data Swarm at Facebook, which was created in 2007. So Airflow is very, very similar to Data Swarm, at least it's at the time that it was originally created. So, that is what it is. If your primary evaluation criteria is like, I want something that has the most history, kind of definitionally a new thing is not for you. And that just is what it is. It's incumbent on us to provide enough value to, make that trade-off make sense.
Very cool. Yeah, I mean, I've done a lot of consulting Airflow work, and I helped to deploy it at Overstock.com when I was there a few years back, before you guys were around. And I'm familiar with its strengths, and I'm also familiar with like the kind of tech debt that's been there all along, and it's very hard to remove, which is what they've struggled with in Airflow 2.0. So, yeah, I think Joe and I will be very interested to talk to you in how we can start using Dagster with some of our clients, because it's
awesome,
very cool.
No, actually, some of our most ardent users are consulting firms. We actually have a consulting firm we work with called Thinking Machines in Southeast Asia, and they're deploying us to huge telcos and financial services across that geo, which is super cool to see. I think the consulting folks like it because of the infrastructure flexibility, and they can kind of build a toolkit that spans different kind of client configurations.
I'll tell you, like, mostly we try to stay away from completely building systems for the client, but we tend to do sort of a collaborative engagement model. But something that's easier to teach and easier to maintain is very attractive for that reason. We did run into problems. We had run into problems with Airflow, like upgrades and other issues along the way, and that was very painful. So
yeah, totally.
So Isla, do you mind if I put you on the spot? You always have good questions. Can I call on you? You may or may not be available to be called on right now.
Sorry. Hi.
Yeah. So do you perchance have a question maybe related to recursion or something like?
Well, we've poked a bit at Dagster and at Prefect Cloud. I guess our main concerns about picking a service like this would be like the amount of support for the core library, and also managed services, because the less infrastructure that we have to maintain, the better. So, and I'm sorry, I jumped in late, so I probably missed some of the detail about Kubernetes. Is this basically cloud agnostic? Could we stand this up in any cloud we wanted to?
Yes. And in fact, the system's very pluggable, because like you can run it on your laptop, you can run it in a K8s cluster, which we have a lot of support for. But we also have users who have like deployed it to their own custom paths, users who have deployed it to ECS, all sorts of different configurations. So infrastructure wise, it's quite flexible in the open source domain. We are in the midst of developing our commercial product, which will involve managed services. So that aspect is coming. And then, we're a venture-backed company with long-term support for the core library. And we will be talking about that more publicly coming soon.
That makes sense. I guess eventually down the road, the managed product would have integrations to secret stores and other ways that you could hook in authentication products, because that would be something
totally
that a company like Recursion would think about too.
Yeah, definitely on the roadmap. You know, all, you know, effectively, you know, if you actually what, you know, we should just ask people this directly. It's like, list all the things you hate, and then see how many of them are operational things that we can offload of you. Like, I hate dealing with secrets. I hate managing servers. And we're like, we do too, but we like our
Yeah,
users,
I think you'd
so
find a good chunk of them would be operational.
Yeah, because I mean, frankly, when I started using Airflow, we had to stand it up ourselves, and having you know, Google and Astronomer come out with managed services was a huge game changer. Like before that, it was very painful, and then just having someone else take care of Kubernetes and all those details was big.
Yep, totally makes sense.
Yeah, because, you know, if I'm going to be frank, you know, we'd be willing to overlook weaknesses in the core library if it came with a really solid managed service that would alleviate a lot of operational pain.
Yep. No, this mirrors like feedback we've gotten, which is effectively, you know, the game has changed with these open source projects. It used to be that people would deploy themselves, and it was like pulling teeth to make them engage with a commercial product. And now it's completely inverse, where a commercial product with ops support is a prerequisite for adoption. And so we are, you know, we consider commercialization, like eventually there's going to be a business model around this, but you know, in the short term, actually the primary goal is to drive adoption more. And that's really kind of our North Star on that.
I have kind of a macro question here. I mean, where do you, there's a lot of data tools right now that it doesn't seem to be ceasing it anytime soon. Like, where do you see the landscape going in the next maybe 3 to 5 years for data tooling?
So there's a lot of different directions you can go with this. I think there's, you know, one aspect we're seeing, and we've been thinking about this a lot because we want to kind of change our positioning and messaging a bit to make our value proposition more clear. And part of that is fitting into the current ecosystem. So, you know, the term that seems to be taking over the most is the modern data stack, which involves a few things, I would say. One is the commoditization of certain activities which can be commoditized. For instance, ingest, that's Fivetran, and Stitch and some more things. And on the other side, everyone's favorite term, reverse ETL, but tools, operational analytics tools like Census are also kind of commoditizing that. So there's some tools which are removing engineers, and then there's some tools which are fully embracing the software engineeringification. 1 second, I think I have to switch cameras for a second. Bear with me.
No worries.
Am I still, can you see me?
Your pic is still there, but I don't see your video.
Okay, 1 second here.
Not a problem. Now we're live.
Oh, and then there's the software engineeringification of data. And so the other component that people talk about in the modern data stack is DBT, right? Which is basically taking analysts and making them analytics engineers. And I think this trend will continue of really embracing software engineering processes across data. And we really see ourselves doing that in the Python layer and really almost in some ways expanding the scope of the modern data stack way of approaching things to more and more things in the domain. I think the other thing that's going to happen in 3 to 5 years is that there has to be a consolidation, because the number of tools and the fragmentation in the space is not tenable for the users and builders we all serve. So there is going to be some sort of consolidating force. There's one thesis that, you know, that it's the cloud data warehouse, that you're going to have the cloud data warehouse eat everything, and Snowflake does SQL, it's going to expand to do, you know, non-SQL compute and Snowpark. They're going to have all lineage, all everything, blah, blah, blah in Snowflake. I'm very skeptical of that. If nothing else, because Snowflake's too expensive. and they can't help themselves. They have to, they got to maintain that stock price. But like people are not going to want to put all their eggs in one basket, in my opinion. And there will be competitor systems that have different organizations, more heterogeneous than that. There's not going to be one cloud data warehouse to rule them all a single org. So there's that. Another thesis is that there'll be consolidation around, say, data catalogs, because this is like a common layer where like there's like a uniform, there's a set of data assets in the org, and you need one consolidating layer to track that. I'm skeptical that that will be the inevitable source of truth, because it's very heavyweight to integrate with all of them, and there's really no guarantees that the data in there is correct. Because like, you can do anything with the data catalogs. And to me, that leaves the orchestration layer, which I believe is the natural place to consolidate data platforms, because it's the orchestration layer, one that orders the computation. So like it can do verifiable things and do asset lineage and with much stronger guarantees. And it is the thing that will touch every single storage layer, every single computational runtime. So kind of broadly, there has to be some consolidating force. There's a bunch of different theses around that. And I think I'm biased for obvious reasons given the company I founded. But I firmly believe the orchestration layer is like the critical leverage point that spans all the other technologies.
When I posted a link to this meetup today on LinkedIn, a friend of mine wrote, it still seems like there's a lot of consolidation going on. There's a lot of tools. He handles more, it's Dimitrios Brinkman. He handles the MLOps community. It's interesting because you have the data engineering community and you have the MLOps community over here. And I think they're kind of two peas in the pod, but he brought up an interesting point, where also there's like Metaflow and other technologies like this from like Netflix and so forth. And but he sees these as being similar to what Dagster is doing. I mean, do you have an opinion on where maybe MLOps or ML engineering sort of overlaps with tools such as Dagster?
Well, in general, I don't think that there should be such a wall of separation between these tools, because in the end, ML engineers, first of all, most of their job is ETL anyway. Data processing more generally, right? It's kind of that classic Google slide that's in every single talk ever, where like they have all this stuff with machine learning, and then the actual model training is like this little pinpoint in the middle, and the rest of it is all what you would consider 80% of it, like generic data engineering issues. They use slightly different technologies. They're much more apt to use, say, pandas or scikit-learn or TensorFlow versus, data engineers generally have a different tool set. But, in my view, a lot of ML ops companies are really data ops companies. And, it's just kind of a reflection of the current organizational silos. And, to be honest, like a lot of the users that gravitate towards us are the people building ML training pipelines, because they work in Python. The whole like model of building pure functions in Python and then being able to easily distribute that compute and use that for orchestration makes a ton of sense to them. They can use their asset catalog to track trained models. That makes a ton of sense. So I think it's very natural that we're viewed with overlapping with those more ML specific tools. You may see us articulating ourselves a different way to reflect that.
Interesting.
Yeah, good.
Yeah.
Because I think orchestration is the heart of any ML platform. There's like model serving and stuff, which we don't touch, but the core ML training pipelines are fundamentally data pipelines.
Mm-hmm. Yeah, it's kind of weird because I see it almost as like these two, on one hand, two parallel universes going on. There's like ML, but then you start looking at the overlap. You bring up data ops, for example. Like I can't see much of a difference between like observability and ML and observability with data in general, right? So yeah, I mean, as Matt and I are, toying with this idea too. I see there's just in the book of writing, we're just thinking a lot about this whole space right now. And it's like consolidation is probably going to happen in tools, but it's also going to happen, I think, in sort of between ML and data engineering. I just think these are kind of false dichotomies in a lot of ways, but I don't know.
Yeah.
We're getting kind of meta here, but
No, it's a really interesting discussion topic. Like, I view the moment that you start productionizing an ML workflow, that is effectively data engineering. Like it is the same process of building a Dagit compute that consumes and produces data assets.
Yeah.
And yeah, we're one of the things we're really excited about is actually integrating with we're really thinking about how we would integrate with kind of notebook-based workflows that ML folks use. Because we found because the code you write in Dagster is fairly plain old Python, and you can also execute your orchestration graphs locally, it's actually very natural to kind of start coding in a notebook and then kind of rip out the code one by one and plop it in a DAG as you go. One of my colleagues calls this process building Roman roads, meaning like as you're exploring your space, you like build roads as you go along and like find checkpoints, right? And so the analogy there would be like, you start exploring in a notebook, you find a checkpoint, you move the stuff over into plain old Python and Dagster, and then you're kind of like using both tools at the same time. The other approach is using a technology called like similar to paper mill, where you can invoke a notebook as a function itself. And we also have an integration with that. But I think it's like, yeah, I think that productionizing ML pipelines is data engineering, it's data processing, and a lot of people use Dagster very successfully for that.
Interesting. Matt, this may get over your big complaint about people developing locally on Jupyter notebooks.
Oh no, completely agree. I mean, yeah, the thing is, like, in many respects, data scientists should be doing their data exploration locally. I just think there's this huge wall between like local data exploration and data engineering, and there's this, partially it's a communication problem, partially it's a tool set problem, partially it's because maybe data engineers need to get a bit better at pandas and data scientists need to get a bit better at like some heavier duty tools. Even things like SQL just get better at like building pipelines that could process a lot of data instead of sucking it onto just a local machine. But yeah, anything that like sort of manages that code evolution process, the refactoring process, is going to be a really positive development.
I got another question for you. So my team we're looking at the midterm roadmap of 2 years, moving to Azure Data Factory and SSIS. What would be the selling points for someone going down that path to not go down that path and go Dagster instead?
I'm not particularly familiar with the details of those technologies, so I will have to take a pass on that and get a homework assignment about. I mean, I could, I think that would be an hour-long meeting of me asking you questions about what the value proposition of those particular tools are and the workflows are. So you have touched the gap in my knowledge, and I won't pretend to know what I don't know.
Okay.
How hard is it to, I mean, I guess if you just had the Azure client library, then you could use Dagster with anything in Azure in principle, including Data Factory. Is that right?
Totally. I don't know. Like I said, I don't know much about Data Factory, so I don't know if it's an orchestration tool or a pure computational runtime or.
It's kind of like managed Spark, basically.
Yeah.
So,
okay.
Yeah, it's kind of like Glue.
Yeah, or Cask. Are you familiar with Cask, the Google bot? Data Fusion now?
Yes. Okay. I'm familiar with Task in that I know I know one of the founders.
Okay.
And then, but yeah, Glue has an orchestration layer. Glue's an odd one, actually. I think it's like data catalog, but it also does host some compute. But yeah, I mean, if it's just like a pure managed compute runtime, a la like Spark, there's nothing that prevents you from invoking it from within Dagster. Yeah. But
I mean, could you just run on like Azure Kubernetes or something?
Totally. Deploying on Azure is, fine. And, spinning this up on K8s is relatively straightforward. Like we have a Helm chart. And as far as I know, we have people deploying to, I'm trying to think, I think someone on Azure K8s, but certainly on EKS and GKE.
Does that answer your question, Mark?
Yes, it does. The only other obstacle is that I'm the only one on my team that knows Python. So,
Oh,
so they're all
Yep.
SQL guys.
Yeah, I mean, to be clear, if your entire transform layer is in SQL, DBT is the tool to use, and then the Dagster comes to play when you need to orchestrate that with other tools, or you're doing data processing directly in Python. One of our users said, what DBT did for our SQL, Dagster did for our Python. So if your whole team is SQL based, highly recommend looking at DBT.
Thanks.
I have a question about integration points in Dagster. I really like the idea of making assets first-class citizens. And I'm wondering if you have any plans to integrate with metastores, like Hive Metastore, Glue Metastore, to populate them with assets.
So yeah, we're actually talking to one of the two companies, Acral Data, that does Data Hub, for example, and that's one of these meta stores. So we certainly support those, because the asset catalog that we have, we consider kind of like an operational asset catalog, meaning very, very specifically about the data observability and ops side of things. And those other data catalog products are way more expansive than that. And so, it is inevitable that folks will want to ingest our metadata stream and populate other data catalogs. We don't preemptively build that kind of stuff because we're waiting for user demand for that, but certainly nothing philosophical opposed to it. And we will be building kind of generic abstractions to make it easily just to ingest this event stream we create and then funnel it to different meta stores.
Makes sense. And so there's another integration point where your tasks, or solids, I guess, as we call them, would invoke ETL pipelines, right? So for example, we use AWS step functions for a lot of our orchestration, like blue jobs and stuff like that. And they provide very rudimentary functionality and does really well. And being serverless is just, it's awesome. And they have those integration points with Athena queries, with glue jobs, etc., that are specific, and they handle, for example, retry and whatever out of the box. Are you planning to provide those ETL or data transformation specific integrations?
Certainly, we have out of the box integrations with, the likes of BigQuery and, lots of different tools. We have dozens of integrations with tools like that. In terms of step functions, we do not have any direct integrations with that. It would, so if you're asking about that, step functions is kind of its own orchestration layer. We could theoretically actually build an integration similar to what we do with Airflow, where we effectively compile Dagster DAGs into the step function, like JSON format or whatever. But there's no active plans to do that. But certainly at lower level, the same way that step functions interacts with Athena, we have integrations with tons of other systems.
Okay.
Those are all open source. And
yeah, that's what I was asking about. I wasn't really asking about integrating with step functions, but using step functions as an example of integrations.
Yeah.
Cool. Any other questions? Use cases you could see using Dagster or orchestration in general? Cool.
Well,
Nick, thank you very much.
All right, awesome. I think I'm gonna sign off. My kid's about to go to bed, so I can, go say hi.
Talk. Thank you.
This is such
all
a
right.
great
Thank you so much.
Yeah, thanks.
Please feel free to come to our Slack, say hi if you want to follow up,
right.
Or you can get Joe. Joe can give me can hand out my contact information.
Just hit me up.
Pop me an
I'll be the
email.
hub. So
all right, awesome. Thank you.
Thanks. All right, bye bye. See you.
Take care.